4.1 inverse functions. What?
I don't have lunch. Wow. I have lunch. It's mac and cheese. I know.
Okay.
I don't want to go to
A one-to-one function
or forensics. I'm ready to be done after this. Me too.
is a function
I think it will go.
that, why did I just, okay.
I love that.
A function that if for elements A and B in the domain of F, A is not equal to B implies F of A is not equal to F of B. That is different values, bless you, of
So much today.
the domain correspond to different values of the range to test this. We have a horizontal line test. Just similar to the vertical line test, but it says that a function is one-to-one if every horizontal line intersects the graph of the function at most once. So for example, if we had these two graphs, so say we had a graph that looks like this, and then a graph that looks like this. The horizontal line test, we're looking to see if it intersects more than once. So this intersects 1, 2, 3 times. So that would be that is not one-to-one. But then this other one, as you go down, it only is ever intersecting once, so that one would be one-to-one. So then some ways to determine, other than just graphing it and looking at it, if a function is one-to-one.
Oh gosh.
First, show that f of A is equal to f of B implies A is equal to B. This means f is one-to-one. 2 in a one-to-one function, every y value corresponds to no more than one x value so we could find at least 2 x values that produce the same y value. We can sketch the graph and use the horizontal line test, which is the one we talked about a minute ago. And then the last one, if you either have a graph given to you or you want to sketch it, if the function increases or decreases, but not both, on the entire domain, so like it only does one of them for the whole graph, then it is one-to-one. So that would have been like the second graph that we drew a second ago. Some one-to-one functions can also like undo each other. We call those inverses. So we will be finding them, but we'll also be verifying that two functions are inverses. So to do that, inverse function, let f be a one-to-one function, then g is the inverse function of f if, so this is going back to composite functions, f of g of x is equal to x for every x in the domain of g, and so these both have to be true, g of f of x is equal to x for every x in the domain of f. To find the inverse of f of x, it'll have to be one-to-one, but anyways, we first swap x and y, and then we solve for y, and then we replace y in what we just found with f to the negative 1 of x, which means inverse. All right, and then just some important facts about inverses. First one, if f is 1-to-1, then f to the -1 or its inverse exists. 2, the domain f, or the domain of f, is the range of f to the -1, the inverse, and the range of f is the domain of the inverse. Three, if the point AB lies on the graph of f, then the point BA lies on the graph of f to the -1. The graphs of f and f to the -1 are reflections of each other. Across the line y equals x. And the last one, to find the equation for f to the -1 swap x and y and solve for y. And I realize we already wrote that one, but anyways.